Greetings, families. Mr. Koga here with a little bit of our math talk from today. So today we talked about math tools, and here are the various math tools we have in our classroom that we use normally. So we have these counters that are red and yellow, they're foam. We got the unifix cubes. These ones can kind of click and stack together. We got the 100 chart. This one goes up to 100. But we also have a 200 chart that we started using this year because we found a need for it. We also got the number racks, the ones that count to 20 and the ones that count to 100. We got whiteboards and an open number line where the number line is right there, and then we start to do jumps based on place value. So then we also have the place value blocks where the kids can actually build the numbers, and we basically had a talk about when is it appropriate to use certain tools, and if you want to be accurate, especially when you get up to the higher numbers, up to 1,000 or even numbers beyond 1,000, what tool is really the best tool? Like, we had a big talk about these counters. They're great for going up to 20, but are they great if you want to go up to 100 or even beyond 100? So we had these talks about, when we're trying to be accurate, trying to be efficient. That's the big thing in second grade, efficiency. What do we want to do? What do we want to use? So here's a big tour of all of our math tools that we have in class and that we use regularly. All right, so we're gonna focus on one problem. I'm just gonna walk you through a bunch of stuff regarding this one problem, 48 plus 67. This one in second grade, that's a big one. We're gonna get into the hundreds, but once the kids can unlock this is like a final E stage. This is like when you unlock the regrouping and you get it, then the whole world starts to open up, and there's a lot of patterns and connections that can be made here. Okay, so we're gonna look at these first. The counters. Now, if you're using counters, we're going to talk very briefly about it, but you look at this and you try to imagine you have 48 of them and then 67 of them. What is the chance that you're going to miscount? What's the chance that the piles are going to become confused or they're not going to be accurate? Big chance for error with these guys. So these are great when you're calculating small numbers under 20. When you start to get over 20, not as reliable as some of the other math tools we have available. The next one we're going to look at are the unifix cubes. Now, these ones are basically the same as these base 10 blocks, but there's a big difference here, is that the kids, when they're doing this right here, 8 plus 7, when they have those cubes, like let's say I'll build 8 here, and then I'll build 7 right here, what the kids can actually physically do is they can physically click them together and feel the regrouping actually happening. And they can actually, actually see the movement and the regrouping, because what we want them to see is that these make they make a 10, or they make the next place value. So unifix cubes are awesome because it actually shows the physical movement, and they can feel the tactile click together of the regrouping. So these are great for not only adding but also subtracting. The next tool we use a lot is the 100 chart. This guy. And here's a little interesting thing, because we were using this all at the start of the year, but once you get to a little bit bigger problems that go beyond 100, this one doesn't work as well. You're gonna have to use something a little bigger, like a 200 chart. So this is what we're using. So for the 200 chart, you usually take the bigger number, 67, and then we add 48. Now, when you do jumps on a 100 chart, going down adds 10, going up takes away 10, going to the right adds 1, going to the left takes away 1. So we're going to start at 67, and we're going to add 4 10s. So we're going to go down 4 steps, 10, 20, 30, 40. Then we're going to add 8 1s by just jumping over. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 115. Now, this is huge because making that jump from 100 into this 120 area, this is where the numbers get real confusing for the kids too. So having this 200 chart that extends beyond the 100, powerful stuff. Okay, the next one, number racks. So this number rack can be used into the millions. We made some great connections because this number rack is not just for adding up to 20, because when you look carefully at some of these other problems, I'm gonna do the exact same problem. When we're doing this, I told the kids, like, I'll kind of stack the numbers up to make it more clear. But I told the kids, when you're doing 48 plus 67, you aren't actually doing 48 like dots plus 67 dots. What we're really looking at is 8 plus 7. That can be done on this number rack with ease. 8 plus 7, 15. And then you go over here, and then we made another 10, so we're regrouping. So then we reset, we got 4 plus 6 plus 1. 4 plus 6 plus 1 more, 11. So again, the number rack can be a huge tool for not just tackling small numbers that only are up to 20, but I told the kids when you are adding two numbers, the biggest number you can ever make when you add two numbers is 18. So that's why this tool could be perfect when you got to add two large numbers. And this can go, like we talk about these kind of numbers. This is what we're talking about in class, because I want the kids to see like doing this 48 plus 67 is the same thing as doing this. It's just patterns. That's all it is. So we use this 20 rack, or we also have this 100 rack for when we're doing maybe a little bit smaller numbers, but also it could be used for all of these. But awesome tools, awesome tools. Okay, the next one we're going to look at is the place value blocks. So these are the base 10 blocks, because they call them base 10 because they move in tens, obviously. So I've already mentioned this before, but when you got 10 of these bad boys, they click together to make one of these bad boys. Again, connection to the unifix cubes. What the difference is though, is that we go through this progression called CRA, concrete, representational, and abstract. These unifix cubes are concrete because you can break them apart. Each unit represents one thing, but then these become a little bit more representational because you can't actually click them apart. A student has to know that this big long rectangle means 10. Sure, they can count them, but it's a representation of 10, because especially when you look at it this way. This shape means 10. This small square means 1, and then this bigger square means 100. So this is a great tool also for modeling this, because just like the unifix cube, when you get a bunch of these out here, you don't click them together, but what you're doing with these is called a fair trade. You're basically going to take 10, so 2, 4, 6, 8, 10, and if you have 10 of these, you fair trade them. So instead of clicking them together, you take these away and you say, okay, I'm going to exchange them for one of these now. And that's the regrouping. That's the 7 plus 8. That's the carry the 1. That's where we're all trying to make connections to right here. All right, so then that's the base 10 blocks, but then now we move into the whiteboard, because the whiteboard can be this tool that really unlocks all kinds of stuff. And now we're moving into the abstract, because instead of being able to touch it and move it and break it apart, now it is all living in these drawings, these representations. So the way we do it usually in class is that we do decomposing. We'll break these numbers up. So 40 and 8, 60 plus 7, and that is much easier to work with. 40 plus 60 is 100, 8 plus 7 is 15, 100 plus 15, 115. But we can even do other methods, because what we're doing now is that these are all math tools. These are the things we touch, and this is how we solve the problems. But now we're moving into the math strategies, and that's more like a recipe to follow to get the result. So instead of 48 plus 67, ooh, those are both not super fun numbers. Ooh. We can do this. We can distribute the numbers and sprinkle them around. So I want to take 2 from here and give them here, because isn't that easier to work with, 50 compared to 48? And then look at what 67 turns into. I like that number better too. So now we can even just look at the place value. So with the 1s, I get 5 1s, and the 10s, I get 11 10s. Bada bing, bada boom. There's all sorts of different ones you can do here. You can even do a compensation. Wait, so instead of 48 plus 67, just make them 50 and 70. And then you just keep track that you added 2 to this one and 3 to this one. So at the end, you have to take away 5. A little bit more advanced technique, because you're doing some you're putting some in to remember to take them out later. But all of this all works, because that equals 120. 120 minus 5, 115. Did we get the same answer? Yup. So there's the whiteboard. And this is, again, math strategies called decomposing, compensation, and then or this might be compensation, but we're basically playing with the math. We're playing with the numbers and making a 10, and then compensation. All right, then the final one I want to show you guys is the open number line. I believe this one is probably the most procedural. Now, when I say that, I mean when we learned math and it was the carry the 1, don't show your work, and you have to follow a lot of steps. This is one that you have to follow a lot of steps. So our problem is 48 plus 67. I always put the bigger number first, because then we do less jumps in the end. So then we start jumping by place value. So we have 40 here. So we're going to do a jump of, you could do 10s or just go 40. Because I know my place value. That's going to be 10 10s and 7 1s. Then I can do 8 jumps. 1, 2, 3, 4, 5, 6, 7, 8. Land there. And then I just count on. 107, 108, 109, 110, 11, 12, 13, 14, 15. So all these tools, all this stuff connects, but it does go in a little progression from being a one-to-one correspondence where you can touch this stuff, you can click them together, to being more representational where the things start to represent these ideas and concepts and numbers. And then we start to move into the abstract where these symbols are now representing the quantities that we were once able to touch and hold and move around. And now we're trying to get the kids to move from this to this to this. But if you skip over this and you don't understand exactly how they all connect, then this becomes much, much more difficult. So that's the whole egg we're trying to crack this year. But we're doing it. It's making sense and it's feeling good. So hope it made sense to you guys. Hope you guys enjoyed.